Hello all, let's start section 6.1 or chapter 6. 6.1 is about a topic which we call it matrix, and in 6.1 we cover matrix solutions to linear system. But before we start talking about the matrix solutions to linear system, let's first find or let's answer first this question. Up my pen. What is a matrix? First, we have to know what is a matrix. Then, after that, we can use it, correct? Those of you that you had intermediate algebra before, you may saw this topic in intermediate algebra. Some of professors, they are covering it. Some of them, they skip this chapter or this section. But here in college algebra, again, in some classes, they skip. In some classes, we teach. What is a matrix, correct? Let me write something for you. Let me give you kind of definition, correct? Matrix is a rectangular array of numbers. Correct? Arranged in rows and columns. And placed in brackets. This is a definition that I just write. Maybe totally not a clear definition, but what is a matrix? I want to give you an idea. It's a rectangular array of numbers placed inside brackets. Correct? When I draw this bracket, and if I place numbers in it, for example, 1, 2, 4, 5, this construction or this model represents a matrix. Correct? As you see in this simple definition that I made for you, a matrix has rows and a matrix has columns. Correct? If you see it this way, these two, which I'm circling it with black color, these are rows of the matrix. How many rows we have in a matrix? Correct? Or if you go this way, a matrix has also columns. Correct? In general, this construction or this shape that I made here for you, we call it a matrix. Correct? The numbers that we place inside any matrix, we call them elements. The elements of a matrix. The numbers that you place in a matrix, we call them what? Elements. Now, this was a very basic information about matrix. Of course, there is an order in matrix. For example, you can call this one row 1. You can call this one row 2. You can call this one column 1. You can call this one column 2. Right? We name how many columns we have, how many rows we have, and in general, what is the size of this matrix. Even these informations are not in your book. We gave them a size also. For example, this one is a 2 by 2. We write this way, a 2 by 2 matrix. It means it has 2 rows and 2 columns. And if the number of rows and number of columns are equal to each other, we call those matrices a square matrix. Correct? 3 by 3, 2 by 2, 4 by 4. They are coming in different sizes. Where is the use of the matrix? We use matrices a lot in our daily life. We use it in communication. We use it in computer science. Even a lot of some hospitals, they are using matrices. Some police departments maybe use the matrices to know the number of staff. For example, how many people are working during the day shift, how many people are working during the night shift, those kind of stuff. We use it when we do surveys. Even later in this chapter, you will see we do some coding with matrices or with matrix, correct? You can send a word in a coding of number, and on the other side, the person who received that matrix, he can decode it, correct? And read your word, what you send, or what was your message to him, correct? We use a lot matrix in our daily life, and this is one of the main topics of science, or I can say nowadays algebra, that we use. Now, you got a little bit information about the matrix, correct? Now let's talk about augmented matrices. Which type of matrix? We call it an augmented matrix. Let me put here a system of linear equations for you. For example, 3x plus y minus 2z equal 4, 4x plus 2y plus 4z equal 1, and x minus 3y plus z equal, let's say, 5, correct? I can write the system of linear equation as a matrix for you, correct? But two types of the matrix. Number one, I'll draw a matrix. If I just place the coefficient of the variables in my matrix, I will call this matrix the coefficient matrix. But if I place the coefficient of my variables plus the constant in this system or in this matrix, I call such a matrix an augmented matrix, correct? How you place always, or how to write a matrix when you see the system, because in this chapter we are using matrix to solve the system of linear equations and 2 variable, 3 variable, 4 variable. I don't care how many variables they give me, as long as I know how to use matrix, I can solve all of them, correct? How to first write an augmented matrix? What you do, copy first the coefficients of all variables, correct? Look at your equation number 1. The coefficient of x is 3, the coefficient of y is 1, and the coefficient of z is negative 2. correct? Be careful to do not lose a sign when you copy the coefficients. Equation number 2, the coefficients are 4, 2, and 4. Equation number 3, the coefficients are 1, -3, and 1. Now, let me make a little bit more space here. How to write the constants? What we do, we draw a vertical line between the coefficients of the variables and the constant term. Actually, the meaning of this vertical line inside the matrix, which we call it a vertical bar, right? Or vertical line. The meaning of this is this equal sign here, correct? 3, 1, -2. What is the constant on the equation number 1? 4, correct? 4 to 4, constant is 1. 1, -3, and 1, the constant is 5. I call this matrix augmented. Correct? In your book, they are jumping from here, there, from one side to the other side, from one topic to another topic, because they think that you studied the beginners of the matrix in intermediate algebra, but with all the changes that come to the system of education, and we barely have intermediate algebra classes now, and I know most of you just came to college algebra, I'll go more in detail. I'll go a little bit slower, explain it to you, correct? Now you know what is an augmented matrix. If I put another example, how to write, for example, let's see this one. 2x plus y equal 4, -4x minus y equals -5. If I want to write the augmented matrix for this system, I will write this way. What is the coefficient of x in equation number 1? 2. What is the coefficient of y in equation number 1? 1. And I'll draw my vertical line and I'll put the constant on this side. For equation number 2, it will be -4, -1, and -5. And this is my augmented matrix for this system. Another example. Let's say 3x plus 4z equal 9, 2x plus 3y minus 2z equal 8, and 5y plus z equals -1. Correct? How to write the augmented matrix for this system? Equation number 1. Look at equation number 1. This system is actually a system of linear equation in 3 variables. But in equation number 1, in this equation, clearly you can see y is missing. If you want to complete this equation, actually this equation is like this. 3x plus 0y plus 4z equal 9. Am I right? Agree with me? Y is not there here. 0 times y, it means y is not here. But when you complete, the coefficient of y is actually 0. When you write your augmented matrix, be careful to replace any variable that is missing in your system. Replace it with what? With 0. Correct? Now, I will write 3, 0, 4, and 9. Equation number 2, 2, 3, -2, and 8. In equation number 3, actually x is missing, correct? It means it's like this. You have 0x here, correct? Then I'll put 0 in X, correct? 5, 1, and -1, and that's my augmented matrix. The other way, if they give you an augmented matrix, you should be able to write the system of linear equation, or I can say vice versa of this topic, correct? I give you the system, you write the augmented matrix. I give you the matrix, you should be able to write the system. Let's do an example like that. I know they are not in your book, correct? But soon you will use all of these in next topic. For example, if I give you a matrix like this, let me do a very easy example. X plus 2y. Sorry, a matrix, not x plus 2y. For example, 1, 2, 4, -1, -5, and 8. You should be able to write a system of linear equation out of this matrix, correct? The numbers on the left side of the vertical bar are the coefficients. Of course, I see I have two variables. One of them is x, and the coefficient of x is 1. We don't write 1x, right? We write just only x. Then I have a positive 2. It means I have a plus sign here. The coefficient of y is 2. It means 2y. Vertical bar means equal, and my constant is 4. For the second equation, I have -x. Then I have -5. It means -5y equals what? 8. Correct? This is how I practice with you. You have to go step by step, analyze it, learn it. Correct? Next topic, let's slowly start the operation, because the actual topic in 6.1 is operation of the matrix, correct? Let's talk about matrix row operation. Let me say it this way. Matrix row operations. I'll give you actually some rules here. I'll try to write it down for you, correct? Try to memorize. They are not difficult rules. They're really easy rules. I named them rules, but they are not actually. Basically, somehow they are the easiest rules, correct? Number 1, 2 rows of a matrix may be interchanged. Correct? For example, if you see such a symbol, R1, then this line and both sides 2 arrows. R2, it means interchange R1 with R2. Correct? Later I'll do example for these, not immediately right now, but later I will show you some examples of how you do the interchange between the rows and why. Correct? Why you want to interchange, where to use. Sometimes interchanging the rows or making the operation of the matrices really easy for us. But remember, we are talking about rows, not columns. Correct? We can interchange the rows. To be honest, interchanging the rows, it means if you have a system of linear equation, you can you can name equation number 1, number 2, and you can name equation number 2, number 1. It doesn't matter, right? Still you have that system. Rule number 2. The elements in any row may be multiplied by a non-zero number. You can multiply the elements in any row. Any row. We are again talking about row operation, correct? The elements in any row of a matrix can be multiplied by a non-zero number. Remember one thing, I just mentioned multiplied, but you know I can change the word multiplied to divide also, because you know actually division is now a special form of multiplying, correct? For example, if I have 2, I can divide by 2, or instead of this, I can say 2 times 1 over 2, right? This is the same. That's why in this rule, we just use the word multiply, but also you can divide, correct? By a non-zero number. The only thing that you cannot do is do not multiply a row with 0, because you will change everything to 0. You will actually erase an equation, right? It means like that. Rule number 3. You see, today the lecture maybe is a little bit long, or maybe I'll divide the lecture in few parts. The element of any row may be multiplied by a non-zero number, and these products may be added to the corresponding elements in any other row. Correct? For example, you multiply a number, for example, a number 2 to the row 1, then you add it to row 2. Correct? Or you multiply 1/2 to row 2 and you add it to row 3, or any other row that you need. correct? This one is actually, this rule is actually the elimination method of the system of linear equation. You multiply an equation with a number to make the coefficients equal to each other, right? Why we make the coefficients equal and opposite sign to each other, I explained it to you, because we want to eliminate that variable. It means change it to 0. Here, that's the case. We use this operation to do that, correct? But remember one thing. When you multiply a number to row 1, for example here, 2 in row 1, and you add in row 2, the numbers in row 1 is not changing. The result comes in row 2. For example, you multiply row 1 like this, 2 to all of them, but you add it in row 2. The change comes in row 2, right? Do not change row 1. Oh, if you just multiply a number to row 1, rule number 2, yes, row 1 is changing. But if you multiply a number to a row, then the result added, or the product added to the next row, do not change that row. Change the row that you are adding that product to it, correct? I will do examples, but that was the 3 main rules of the matrices that I explained to you, correct? Now, let's do some examples. Example number 1. In part A, they are saying interchange row 1, or maybe even they are not using the word interchange. They write like this for you. Row 1 with row 2, and they give you a matrix. 3, 18, negative 12, vertical bar, 21. Row 2 is 1, 2, negative 3, 5. Row 3 is negative 2, negative 3, 4, negative 6. And part A, they are asking you to interchange between row 1 and row 2. It means do this. Write the row 1, all the elements on row 1 and row 2 and row 1, and all the elements of row 1 and row 2. Do this. My row 2, this is your row 2 here, right? And this is your row 1. My row 2 is 1, 2, negative 3, 5. I'll bring it up to the row 1, and I'll bring row 1 to the row 2. 3, 18, negative 12, 21. What about row 3? Keep it as it is, right? Negative 2, negative 3, 4, negative 6. This is how you interchange one row to another row. Where to use? Soon I'll explain to you why we are doing this, correct? Soon I will explain it to you. Part B of this problem is giving you something like this. Find 1/3 of row 1. Your original matrix, not the one that I did it, I changed it, correct? Your original matrix was 3, 18, negative 12, dash, vertical line 21, and we had 1, 2, negative 3, 5, and we had negative 2, negative 3, 4, and 6. They are asking you in part B, find 1/3 of row 1. In your book, they want to show everything here for you. I'll show it 2 ways for you, correct? You can write, you can show the operation what you are doing, or just do the operation easy and fast. Correct? I'm not saying the book is incorrect. No, the book is totally correct. Even they're really good because they want to show the work. But in future, when I'm solving a linear system of linear equations, we don't want to go that long. We just multiply the number, correct? But right now, in this example, I will show how. What is the meaning of 1/3 of row 1? This is your row 1. It means multiply 1/3 to the all elements of row 1, only row 1, correct? Then you can say it's equal. Look, I'll do this. 1/3 times 3, 1/3 times 18, 1/3 times, let me change the color, times -12, correct? Vertical bar, and 1/3 times 21. In a simple language, distribute, you're using the distributive property. Basically, what does it mean? If I have an equation like this, 3x plus 18y minus 12z equals 21, and I want to multiply this equation with 1/3. You distribute 1/3 to all of them, right? Like this. This is what you do in matrix. Some students, when I'm teaching matrices, they're really happy. They say, oh, it's easy. But some of them, they say it's difficult. But look, nothing is difficult here. You just, you do actually 3 operations. Multiply, divide, or add. That's it. Correct? Okay, to do not go away from the topic, root 2 and root 3 are not changing. Just write them down. 1, 2, -3, 5, and row 3 is -2, -3, 4, and 6. Correct? Now multiply 1/3 to all of them. 1/3 of 3 means 1. 1/3 of 18 means 6. 1/3 of -12 means -4. And 1/3 of 21 is 7. Copy row 2 and row 3 as it is. 1, 2, -3, 5, and your row 3 is -2, -3, 4, and 6. That's part B. In part C of this problem, they are asking you to do this. 2 times R2 plus R3. Let's copy our original matrix first here. I had 3, 18, -12, 21, 1, 2, -3, and 5, -2, -3, 4, and 6, I think, right? Yes, 4 and 6. 2 times R2 plus R3. Look, I don't want to write all the steps. I'll do this. This is my row 2, right? I'll multiply here 2 to all of them like this. But before multiplying, write a new matrix. Do I touch the row 1? Definitely no. I'll copy my row 1. Do I bring a change actually in row 2? Definitely no, because I'm multiplying the 2. and row 2, but the result is adding to row 3. The actual change comes in row 3. It means we are not changing row 2. Then copy your row 2 also. This way of working avoid mistakes in future, correct? Now, I'll change the color. 2 times 1 gives you 2, right? Add it in row 3. 2 times 1, 2. 2 minus 2 gives you 0, right? 2 times 2 gives you 4. 4 plus minus 3 gives you 1. 2 times negative 3 gives you 6. Negative 6. Negative 6 plus 4 gives you negative 2. And 2 times 5 gives you 10. 10 plus 6 gives you what? 16. You multiply to the row and add to row 3. Correct? This is how you do the operation of a matrix. I know they're long. I'll stop the lecture, part 1 here, but I'll do part 2 and part 3 immediately because this section 6.1 is too long and there is a lot of information. The basic informations that you need. If you know the basics right now, later 6.2, 6.3, 6.4, they are easy. But if you don't learn 6.1, then it gets, of course, difficult in other sections. I'll stop the lecture here and see you all in part 2 of section 6.1.